In this presentation, I will introduce the concept of Data Governance 3.0 and the data trust architecture for blockchain-based ecosystems. I will show how data are shifting from a byproduct of operations to a strategic and auditable asset, and why blockchain now serves as a technical trust layer. I will also highlight the key international standards, ISO, IEEE, ISACA, and NIST, that together enable trusted, interoperable, and accountable data ecosystems. Modern organizations operate in a highly regulated and data-intensive environment. Distributed ledger technologies and AI are transforming how data are created, shared, and used. At the same time, regulations such as GDPR, DORA, NIS2, and the AI Act require transparent, auditable, and accountable data handling. Data become a real asset only when they are trusted, when their integrity, provenance, and compliance can be verified across organizational boundaries. According to ISO 8000, data quality is the degree to which data satisfy the requirements of their intended use. However, in decentralized and automated environments, this is not enough. We need data trust. Data that are not only correct, but also verifiably authentic, traceable, and accountable. In this paper, data trust is described through 4 pillars: integrity, data are not tampered with; provenance, we can trace their origin and transformations; accountability, we can assign responsibility; and transparency, stakeholders can independently verify data quality and policy compliance. Traditional information management mainly focused on storing and protecting data as a supporting resource for processes. In the data value management perspective, data are treated as an asset with measurable value. They become data products with a clearly defined owner, quality levels expressed in services level agreements, and a documented life cycle and business purpose. In Data Governance 3.0, the value of data is strongly coupled with the level of trust they can provide. Trust that is increasingly supported by blockchain-based proofs of integrity and provenance. Existing data governance frameworks such as COBIT, DAMA DMBOK, or Data Mesh are usually discussed separately from blockchain standards. Conversely, DLT standards focus mostly on protocols and security, not on their role as a trust layer for data ecosystems. This creates a gap. There is no integrated model that combines data governance, blockchain-based trust, and concrete standards. The paper addresses this gap by conceptualizing Data Governance 3.0, proposing a 4-layer data trust architecture, and mapping it to ISO, IEEE, ISACA, and NIST standards. The paper makes 3 main contributions. First, it defines Data Governance 3.0 as an evolution of previous governance models, where data value is explicitly linked to verifiable trust. Second, it synthesizes a broad set of international standards into a coherent 4-layer data trust architecture. Third, it proposes an interpretive framework for designing trusted, accountable, and interoperable data ecosystems in which blockchain acts as a technical trust layer for AI-driven systems, data mesh environments, and compliance as code mechanisms. The evolution of data governance mirrors the evolution of digital society. Early models, which we call Data Governance 1.0, emphasized strong centralization and control, often in stable corporate environments. Around 2015, Data Governance 2.0 emerged with federation, data mesh, and automation of governance. Today, Data Governance 3.0 addresses distributed, AI-enabled, and highly regulated ecosystems where trust, accountability, and decentralization become the dominant themes. The key shift is from managing isolated databases to orchestrating a trusted, interoperable ecosystem. In Data Governance 1.0, the dominant idea was to create a single, consistent organizational truth. Central data teams defined access rules, quality checks, and compliance procedures. Standards like ISO IEC 25012 and early ISO 8000 editions focused on accuracy, completeness, and consistency. However, they did not yet address trust, accountability, or ethical aspects. This model worked reasonably well in stable and centralized IT environments, but proved insufficient for distributed data flows and real-time analytics. Data Governance 2.0 appears with the rise of big data and cloud computing. Concepts from DAMA DM Book 2 and the data mesh paradigm emphasize federation. Domain teams own their data products and are responsible for quality and usefulness. Data marketplaces emerge, and governance rules start to be automated as code. However, even with COBIT-based audit frameworks and ISO 8000 and ISO 27000 series, these models do not fully embed trust and auditability at the architectural level, especially in cross-organizational settings. Data Governance 3.0 evolves in response to AI-driven automation, blockchain-based infrastructures, and stricter regulations. ISO TC 307 standards describe blockchain as a trust layer that records every operation and change in an immutable ledger. Governance becomes decentralized and interoperable. Accountability is supported by cryptographic evidence, and policies are enforced through compliance as code. At the same time, Data Governance 3.0 aligns with FAIR principles and the NIST AI risk management framework, ensuring that data are not only technically trustworthy, but also ethically and legally compliant. Data trust is not a single standard, but an ecosystem of interrelated standards and frameworks. ISO IEC 8000 and 38505 define how to govern and measure data quality and value. ISO 23258, ISO 22739, and W3CDIDS provide the language for identity and provenance in distributed systems. Draft standards like ISO 23353, along with ISACA frameworks and NIST documents, create a basis for auditing integrity and security. Finally, ISO 23257, IEEE 2418, and compliance as code approaches enable interoperable and automated rule enforcement across networks. The data trust architecture acts as a trust backbone for modern data ecosystems. Its main goal is to verify the quality, provenance, and use of data, regardless of the underlying systems or organizational boundaries. It combines organizational governance, such as roles, policies, and accountability, with technical trust mechanisms like cryptography and blockchain. The concept is grounded in ISO IEC 38505 for data governance, ISO 22739 for blockchain vocabulary, ISO 27001 for security and related ISACA and NIST guidelines. The data trust architecture is composed of 4 interdependent layers. The governance and policy layer defines who is responsible for which data, what policies apply, and how quality is managed over the life cycle. The identity and access layer manages decentralized identities, credentials, and access control mechanisms. The integrity and provenance layer provides cryptographic proofs and immutable ledgers, making data tampering detectable. Finally, the interoperability and automation layer connects different systems and domains using smart contracts and compliance as code to automatically enforce rules and enable data mesh-style collaboration. The data trust architecture introduces clearly defined organizational roles. The data owner is responsible for the value and policies related to specific data sets. Data stewards ensure day-to-day quality and integrity within domains. Trust authorities or operators maintain the trust infrastructure, such as blockchain networks or audit systems. Data consumers, which can be humans, applications, or AI models, rely on trusted data for decision-making. Finally, auditors and regulators use distributed ledgers as independent evidence sources to verify compliance with frameworks like GDPR, DORA, or ISO 27001. Blockchain contributes 3 key trust properties to data governance 3.0. First, integrity. Cryptographic hashes and chain blocks make any unauthorized change immediately detectable. Second, auditability. Each entry includes an author identifier, timestamp, and link to previous blocks, forming an immutable audit trail. Third, compliance. Policies on access, retention, and data protection can be encoded as smart contracts, enabling compliance as code. Architecturally, blockchain acts as an independent data notary that strengthens the credibility of traditional databases and analytical systems. AI, data mesh, and compliance as code reinforce each other within the data trust architecture. AI models can automatically analyze data quality, detect anomalies, and predict information risk, but they themselves require transparent and auditable training data lineage, which blockchain can provide. Data mesh distributes data ownership across domains, while blockchain provides a federated trust ledger for cross-domain accountability and semantic interoperability. Compliance as code turns legal and policy requirements into executable rules, and blockchain ensures that every enforcement decision is logged and verifiable. Together, these elements move us towards autonomous and accountable data ecosystems. To conclude, the transition from data governance 1.0 to 3.0 marks a shift from centralized control towards distributed trust, accountability, and interoperability. The proposed data trust architecture 3.0 serves as a reference framework for designing such ecosystems, combining blockchain, AI, data mesh, and compliance as code under ISO, ISACA, and NIST guidance. Future research should focus on formalizing data trust metrics, enabling semantic and technical interoperability across blockchains, and using AI for dynamic trust validation. Ultimately, this may lead to Data Trust 4.0, intelligent, self-enforcing ecosystems in which data possess their own identity, value, and verifiable history. Thank you very much for your attention.